hotter than the center of the sun. It is so hot that the iron atoms that have sunk to the star's core are torn apart. The core destabilizes.
The cores then collapse on themselves in a fraction of a second. The collapse proceeds to very, very high densities.
The core collapses at speeds of more than 43,000 miles per second. A volume the size of the Earth crunches down nearly 6 times the size of Manhattan in an instant. The core becomes super dense.
If one were to take 1 cubic centimeter of that matter, that would be the size of a sugar cube. That sugar cube would be so dense that it would weigh as much as the entire human race.
The core rebounds like a compressed rubber ball and launches a massive shockwave. The shockwave hurtles out, smashing through the different skins of the star. As it punches through the outer layers of the star, the energy generated restarts the element production line. Atoms are smashed together to make brand new, heavier elements, all heavier than iron. Then the star explodes, and the shockwave pushes the shrapnel-like debris outward, further and further into space.
In a very real sense, our lives depend on the stars in the universe. Without their lives and deaths, we would not be here today.
These astonishing images taken by the Hubble Space Telescope show the aftermath of these giant explosions. Nebulae, giant clouds of debris thrown off by exploding stars. Swirling inside are big new atoms, gold, silver, zinc, and lead. Without supernovas, our world would be a very dull place and possibly lifeless.
So I'm sure that Paris Hilton doesn't wake up every day thinking about this fact, but really, if it weren't for exploding stars, those 200 million stars that exploded so we could be here today, she wouldn't have anything to wear. So if it weren't for those supernova explosions, there wouldn't be any bling.
9 billion years after the Big Bang, and all the ingredients are in place for life as we know it. The universe has grown up into a vast, complex place made up of billions of galaxies and uncountable stars. In a quiet corner of the Milky Way, a mass of dust and gas begins to accumulate. It's full of the rich debris left over from one of the massive supernovas. And when it reaches a critical mass, it begins to burn brightly. A star is born, our own star, the sun. What's left over forms a disk of swirling debris in orbit around the new star. The gas and dust that make up this ring collide, pulled together by gravity. The clumps of dust and gas become bigger and bigger. Planets form. One of these planets is our Earth. Over the next 500 million years, our planet slowly generates a protective canopy of gas, the atmosphere. The first life appears, just single cells at first. But as the eons pass, those tiny single cells evolve into plants and animals, and eventually humans.
We tend to disassociate ourselves from the universe, but that, of course, is completely wrong. We are a vital part of the cosmos. And so when we talk about the origin and evolution of the universe, we're actually talking about the origin and evolution of ourselves.
Everything we can see on our planet was either made in the Big Bang or inside a star. Scientists like Krauss believe they now know the genesis of every atom that has created the world we live in.
These atoms have been around since the dawn of time. And when I was young, my mother used to tell me, "Don't touch that, you don't know where it's been." And she would have been amazed.
But this is not the final chapter in the story. After almost 14 billion years, the universe has really only just gotten started. Now we take a journey into the future to see how it all ends. The universe we live in is nearly 14 billion years old. It has created the raw materials for everything we see around us. The stars, the planets, trees, cities, automobiles, even us. Our world is complete, but the universe is still evolving. Scientists have come up with many theories on how it will end.
We know our universe began in a Big Bang. What we don't know yet is what the future of our universe is going to be. Our universe may end with a bang or a whimper or something even more exotic.
One theory suggests that our universe will run out of steam and stop expanding. Every star, galaxy, and planet, every atom will start to collapse, ending in a single super-dense pinpoint known as the Big Crunch. To find out if the universe really is going to crash back in on itself, scientists first need to discover if it's still expanding or if it's slowing down. Astrophysicist Saul Perlmutter studies the death of the universe by finding beacons in space, exploding stars called Type 1a supernovas.
If you have enough of these exploding stars, these supernovae, that you've measured their brightness, the ones that look fainter and fainter and fainter must be further and further and further away. And so you have some supernovae that are a little bit brighter, they're more nearby, some that are a little bit fainter, so they're a little bit further, and some that are very faint, so they're very far away.
Type 1a supernovas are similar to the supernovas that created the heavy elements. They differ in one important fashion. They always explode with the same exact brightness. This is because they are created in the same way. Two stars circle each other, held together by their gravitational attraction. One is shriveled and super dense, glowing with white heat, a white dwarf. The other star has bloated to an enormous size. It's a red giant that is burning the last of its fuel. As the two stars orbit each other, the white dwarf sucks gas from its companion and begins to grow year after year. When it is precisely 1.44 times the mass of our sun, the white dwarf crumples, collapses, then explodes, releasing a blinding burst of energy. Every Type 1a supernova explodes at the same tipping point, and so are equally bright and visible across the vast distances of the universe. Perlmutter needs to find hundreds of Type 1a supernovas and then measure how fast they are moving away from us. By comparing the positions and dates of all these supernovas stretched over space and time, Perlmutter can calculate whether the universe is slowing down. His results are a shock. The expansion of the universe isn't slowing down at all.
When we began the project, of course, the goal was to find out how much the universe was slowing down. Now, when we actually started looking at the data, it looked like the universe wasn't slowing enough to come to a halt. And in fact, it wasn't slowing very much at all. And in fact, when we finished the analysis, it looked like it wasn't slowing, period. It was actually speeding up in its expansion.
Perlmutter's astounding discovery means that the universe will not grind to a halt, then crunch back down into a pinhead of super-dense matter. Quite the opposite. It will continue to expand faster and faster. Our universe is literally flying apart.
The expansion of the universe will accelerate at ever faster and faster rates until literally everything will get ripped apart. Not just galaxies, but eventually matter, the Earth, all the objects, stars, the Earth, planets, people, atoms, in a finite time would get ripped apart.
Long after our sun has burned out, 100 billion years in the future, galaxies will pull apart. The universe will be made up of isolated stars, which are running out of energy. Some will become white or brown dwarfs. Others will collapse into neutron stars or black holes. Then, thousands of trillions of years after the Big Bang, even the black holes will evaporate, and all matter will decay to its basic ingredients. Atoms will fall apart, and even protons, the building blocks of atoms, will decay.
The most likely future is perhaps the most dismal one, where the universe becomes cold and dark and empty.
As the universe continues to expand and the galaxies speed apart from each other, space will become empty and dead.
Our own cluster of galaxies will be moving away from us faster than the speed of light and will disappear from the night skies.
Eventually, everything will just sort of wind down, and that's the end of things.
Finally, the universe will die, and all that will be left is a cold, dark, and lifeless space.